Thank you. Yeah, thank you for the intro, and thank you for the wonderful panelists up with me here today. Why don't we give just quick introductions about ourselves and what we work on? Gwendolyn, would you like to start?
Thank you so much, Chris. So my name is Gwen, and I've been an operator, founder, and investor for the last almost 20 years. Always in technology and media, so I started and sold a media company. I've started an investment fund with the Singapore government. I'm from Singapore. Done a bunch of things where I launched Asia Pacific for companies like Mashable, Facebook, a special venture capital program. And most recently, I spent 2 years at Binance, where I launched investment and grants for the chain, as well as running part of the BD and partnerships at BNB Chain. So today, I'm representing Horizen Labs. I just joined 1 month ago. Into this very, very technical field of ZK. But Horizen Labs, we do a bunch of things, but one of the key things we are doing is ZK verification. So ZK Verify is a ZK proof verification layer. And we're also launching Horizen 2.0, which is an EVM focused on ZK apps. And we are also the team that launched and helped partner ApeChain. So yeah, a bunch of things. Horizen Labs have been in the space for quite a while, and I'm excited to talk more.
Excellent. Thank you so much. And Sinka, for yourself?
Hi, everyone. I'm Sinka. I'm the founder of the Delphinus Lab. So we are a very small lab that actually provides the reference implementation of the first ZK WebAssembly virtual machine. It's a ZK virtual machine that supports WebAssembly bytecode. And we provide a service to actually giving all the WebAssembly applications a proving service so that they can generate proof and do the trustless settle on chain. Thanks.
Amazing, thank you. And just to break that down a little bit, I think ZK WASM is very interesting. WebAssembly is essentially the technology that you guys find in, if you guys ever use Canva or Figma, or if you do anything online interactively, like Google Docs, that'll use this WASM. And so what they're working on is turning that into verifiable computation, which is very, very impressive stuff. Myself at Zero Computing, we run specialized provers in proving networks. So there's these ZK rollups in Ethereum. They essentially batch transactions on L2s, generate a proof of those batches, and then publish it on chain for a fraction of the cost. We're those people who generate those proofs. And now we're also building some proving infrastructure on Solana as well. So going deep into it, it should be a lot of fun. But sticking with the panel here, so we had a pretty interesting discussion to kick off in the back room. Sinka came in saying, man, it's a bull market, but ZK is not a part of the bull market. And I thought that was really interesting. Yeah, why don't we talk a little bit about that? Why isn't ZK a part of this bull market?
I mean, I'm a guy that actually bullish on the ZK narrative, but from my perspective, ZK technology is very dynamic, right? Still moving very fast. As I said, none of the tech stack actually sustain their peak for more than 6 months. It started with Circum, right? ZK Sync, Plonk 2, Halo 2, and then Scroll Halo 2, ZK EVM, Stockware, and now Risk Zero, SP1, Jolt. Everyone inventing their best technology, but none of the best technology can somehow sustain for 6 months, keeping as the best ones, right? So it's moving too fast. But the bull market is so real at the moment, right? It's very hard to pick what kind of ZK tech will be the end one, right? So it's like another world besides the bull market. It's a slow but steady and very dynamic tech stack. People put lots of effort, but I don't think they actually belongs to this bull market. Thanks.
Yeah, I think that's a really interesting observation. ZK is very dynamic, and there's a lot going on. It's very technical, as Gwen pointed out at the top. Coming in you've been working at ZK Verify for a month now, and this is your first foray into the field. What's your impression so far, and how are you thinking about
Yeah, so technically my first foray, but back in 2017, I tried to do a DID startup. So that was, too early, I think. The tech wasn't ready. So I've always been interested in decentralized identity and privacy, the topic for today as well. But that we put that aside. I think it was, again, too early. But so fast forward to today, why I joined Horizen Labs and why ZK specifically is that I'm super interested in belief in the future of the importance of privacy. You know, Web2 people are posting about their dinners and whatever on Instagram and TikTok and stuff like that. There's almost a lack of privacy. You know, they're sharing their lives with everyone. But as we move towards Web3, again, all our wallets are transparent. I think at some point, more retail people would be a bit more conscious of the fact that, hey, actually, everyone can see literally what I spent on dinner 10 years ago. And slowly and surely, I think this retail conception of privacy might evolve. Again, we're talking about various nuances where you can be private in some aspects and non-private in some aspects. So why ZK Verify and Horizen Labs are doing, focusing on ZK is that, well, the team has been doing cryptography for the last, 7-8 years, and the team is very, very strong in that field. We want to make sure that for the future of the internet, the future of the world, that we can bring more privacy infrastructure to the world. Because we believe that ZK is bigger than Web3. And part of my goal here in Horizen Labs, as I'm overseeing BD, is really figure out the anchor use cases for ZK.
Yeah, that's probably the thing that's most needed now for our field. As Sinka said, we've been building this cryptography and this research for years now, going on to decades nearly. And I think probably one of the troubles of our field is that everyone who works in it, there's this barrier that you have to be like above, you have to be fairly technical enough, and therefore we often lose sight of the forest from the trees, right? And we get down into the technical weeds of, okay, what kind of proving system are we using? How are we arithmetizing our programs? What are the kind of trade-offs between different proving systems? And we lose sight on exactly kind of like the business use cases, which I think also exist. But it takes a different type of person to start, integrating those in and finding and applying it in the right way. So I think it's...
Chris, you're very kind. Thank you.
So Sinka, you kicked off by saying AI is one of the hot fields right now. I mean, is there any way that we can blend these two ZK and AI together?
So I used to buy coins a lot, right? So the angle that I think about why AI would be have strong connection with ZK is that if you would like to hire an AI to do the trading for you, right? You want actually the AI to not interfere by some kind of human beings that are actually manipulating the backend, right? You want the result of the trading is carried out by a particular AI model, right? But how can you actually prove that this AI result is generated from an AI model, right? You have to run the interference of the AI result checker in a trustless way. And the trustless way is what ZK provides, right? So if we can somehow run the Llama interference algorithm in a trustless way, which means run that in a ZK VM and verify that on a ZK verification layer, then you can prove that, okay, all your trading policies that provided by your service provider is actually built on top of a senior AI model, right? Not interference by a human. And all these trading AI robots that can now compete with each other trustlessly, right? So if we're expanding this barrier a little bit larger, then we will say, in the future, lots of service can be provided by AI, right? But you want trustless AI providers. You do not want someone that give you a creeping AI thing, so that you want to prove that the service provided by a certain AI model is directly derived from an AI model. And ZK can provide the policy, the security, and the quality of the AI model by interference.
I would also add that for AI specifically, one thing that's particularly important to me is the decentralization of data, right? Because in the centralized world, AI has been co-opted basically by the big companies out there. So Web3 AI there's so much potential for decentralized data, contributed by everyone. But then again, I would love ZK to be a big part of that, where you can, trustlessly show that you're contributing a certain set of data without showing what exact data that you're contributing to, which which again leads to just, I guess, longer, easier for AI ML to scale.
Yeah, definitely. Very, very interesting. When Sinka was talking about this idea of verifiable inference, I feel like that's something that a lot of us can probably use today. I mean, how many people here have heard of Goat.cs Maximus? Yeah, you guys hold some? Yeah, so this is this AI meme coin, right, that was launched on pump.fun on Solana. And really what it is, it's Andy, the creator of Goat.cs Maximus, prompting his LLM in his own studio, in his office, and then him essentially typing the responses from that LLM back onto Twitter, and that's what gets posted to the Goat.cs X page, right? And so that's, I mean, it's kind of cool. I mean, it's very meme-worthy, but I mean, what's to say that, you know, in the future where you have this use case where you have an AI agent that's responsible for executing some sort of trading strategy, or maybe you actually want a source of truth from this LLM. Maybe it's been trained on some textbooks that you really want to make sure you get the right answers to. How do you make sure that there's not a human intervening that prompt and response process and not changing something along the way? Well, you can use something like verifiable inference to make sure that given a certain prompt, aka like what is the weather today, that prompt is run against this specific model. Maybe it's the Goat.cs Maximus model. Maybe it's a quantum model, and you can verify that the output has not been tampered with, it wasn't changed, and it was actually produced by the AI and not intermediated by a human. So
how would you guard against hallucinations if the AI output is actually a little bit wrong?
Right, so that's exactly a really good point. Like, then we fall into the territory where we have to believe everything that the AI says. And yeah, that's probably a middle ground to be figured out there, which is we can only use this verifiable AI, or maybe you can actually verify that there's certain transformations to the response. So maybe not like a one-to-one comparison to this would be, there's been, Sony actually has a camera where you can take a photo and it'll produce a digital signature of every photo that it's taken, which makes a lot of sense. Like, you just want to make sure that this image was taken by a camera and not produced by AI or modified in some way. And the way that you take that a step further is, let's say you need to crop or you need to transform, you need to modify the image in some way. You can apply some transformation to it, and that's essentially just some sort of computation to it. And that's where ZK would come in. You can prove that I'm cropping a certain portion of this image without distorting anything else in the image. For example, replacing my face with someone else's face. And so maybe there's an opportunity to do.
But you see, even when you crop something, you can crop someone out, and that changes the context of the image.
It does 100%. And so this idea of verifiably cropping someone else is saying, I am cropping this person out, and nothing else is changing. So you're kind of you're asserting a statement and then verifying that statement was true.
Yeah, I think that's so tricky because you may crop out that person. So factually, that person is cropped out without affecting everything else. But this is where facts and media come into play, right? You can write a story about the newly cropped image.
Indeed, yeah.
And hopefully, spin it.
Yeah, hopefully it has. I mean, and this is, I guess, one of the ideas that's been played around is that maybe it's a bit of a dream, but every image on the internet has a kind of like a log or a trace of all of the transformations that it's gone through back to where the photo was originally produced from, whether it's been a camera or via AI. So there's some sort of history that we can verify that what we're seeing actually reflects what we're believing, which is the ultimate goal, right? Yeah. Okay, super cool. So yeah, Regina, Gwen, at ZK Verify, you guys are very interested in privacy. So what kind of use cases and applications are you guys looking at there?
We are very bullish on, like I mentioned, we think ZK is bigger than Web3. So within the Web3 space, we're very bullish on logins, so identity and logins. And we're also interested in proof of SQL, because databases is one big category in which we think, again, will scale to the world, requires like every single piece, every single thing in the world is almost like data, right? So I think that's very, very important. AI is the third category in which we are actively looking at as well. So for all these use cases, where we envision, ZK Verify to be part of is that, for ZK Verify, we can work with different ecosystems. So we're not just EVM, we're built on substrate. So that means that we are way more interoperable, to use that term. So if you are building something in those spaces, you can actually come to ZK Verify. And for us, we are 90% cheaper. Groth 16, for example, is for now about 4 seconds of proving time. So that's pretty decent. All these are still incentivized testnet. So mainnet launched in Q1. So the tech is looking good. It's the use cases now that we are actively trying to prove out. Because I think this, Sinka said, is very dynamic, and we're working with different tech partners, but also, everything from protocols, infra, but also application layers to partner and figure out use cases together, if you will, as well as independently kind of going out there and doing customer discovery.
Yeah, when it comes to finding those partners and finding adoption, are there any geographic regions that you guys have noticed to be more accommodating, more interesting of this tech versus others?
From my side, because currently we are not very active in finding very special use case. We're providing a roll-up service called a CK WebAssembly mini roll-up, but because we found that this bull market is mainly memes and small application and game applications, so what we provide is a very simple trustless computation for meme apps, small apps. So this kind of very traditional use case for scaling the Web3. So from my side, I'm making very small progress on finding new narrative. Thanks.
Yeah, for sure. My official title is APAC, just because Asia we have a lot of users. But I would say there are specific use cases, and I'll give you an example. So I talked about logins, right, and identity. So in countries, the war-torn countries, like Myanmar. So I was talking to some friends there. They're actively working on DID, because there is under martial law. Whoever you are, you have to be very, very careful, because the police and the military can literally just put you in jail for whatever reason. So the team there, some of my friends there, are working on a DID product where you can, basically using ZK, prove that you're either with or without you're not on the opposition camp to military personnel. Stuff like that, which I think is such a direct use case of ZK and so real. Like these people, they are living in fear of their lives. So I see some of these specific use cases for, Myanmar, but this can apply in many other war-torn countries and countries where it's a bit, where the political government is a bit more unsteady.
Yeah, it's really interesting. I've also talked to a bunch of people who are working on DID, and it seems like the company or the countries who are most interested in adopting DID are those countries who face some sort of existential threat, or whose citizens are being treated unfairly. And yeah, that seems like it's obviously a very, very sad situation, but this is like a real use case for getting DID out there, and it is the most important for people who face the questions about whether my state will continue to be a state in 10 years. How do I maintain my proof of personhood? How do I maintain my identity in a world where I have to immigrate into a different country that may not recognize my official status of a country? So yeah, very, very interesting. And coming back to the regional aspect, being in APAC versus, other like Europe and North America, have you seen other kind of sort of governments respond in any way to ZK or DID?
Can I give you an answer in a few months?
Yeah.
I haven't seen enough of kind of global experience, but I can talk, I guess, on a very, very high level. So for ZK Verify Horizen Labs, our team is based in US and Europe. And in Asia, we have just myself and another colleague. So in terms of the kind of adoption side of things, I was based in Paris for a while. So I lived in France. And when I look at a very high level on an overview from an adoption of technology perspective, I would say because the US and Europe in general, they are developed countries, so they have basically more money. And some of the governments, like France, actually, they are very bullish about just onboarding tech. So you have to go down to the different countries and not regions specifically to see, I think, on various levels, how much the government is into tech, and then after that into Web3. Coming down to Asia, you're seeing many countries here, adopting CBDCs as one big experiment, which is a start of Web3 because that's the clearest use case for the government at this point. So I would say I'm extremely bullish about this part of the world because Asia's been leading in the CBDCs conversation.
Yeah, 100%. Yeah, with CBDCs, it's just like it's the start of a whole digitization of government, starting with money, then eventually identity. It gets very, very interesting. Yeah. What do you guys see as some of the biggest wins and maybe some of the biggest challenges for ZK?
Currently, our VM is not the fastest VM in the world. There are SP1, RISC-0 who can actually do 1 million instructions proof in about 4 to 5 seconds in GPU. The WebAssembly is a little bit different because it has 148 instructions. So our proving rate is like 8 to 9 seconds for 1 million instructions. We have applied. Do you know there's a repo called tinylama.c, right? It's an AI interference re-implementation of Llama. So the tinylama.c can be compiled into WebAssembly, and if you run that WebAssembly into our CKVM, it's about 40 billion instructions. So 40 billion instructions for a verified AI result is about, if you times 40 million divided 1 million, or 40 billion divided 1 million times 9 seconds, that's about 11 days. Oh, sorry, I forgot the number, maybe 12 days. So currently, if you do not improve the CK WebAssembly VM speed, then what I've been told before about checking the correctness of a full verified AI inference algorithm is not practical. So that's our current biggest challenge. I hope that we can improve 10 times quicker next year. Thanks.
And for those benchmarks, is all this proving done client side or is it done server side?
It's all done in one single 4090 GPU.
Gotcha, okay.
So I need someone actually building maybe a network for GPUs to do that.
Yeah, exactly. Well, there's a few proving networks coming up, and so hopefully you can start to
I'll
distribute
try
those.
them. I'll try them.
Yeah, exactly. Yeah. From your perspective, Gwen, do you see any wins so far for ZK and any challenges ahead?
Coming back to your first question and what Sinka said regarding the narratives, I think one big potential win is that maybe I'm seeing it a little bit differently from you because you're deep in the weeds right now. But I think ZK as a narrative is slowly coming up in general,
As
right?
a narrative,
it is, right?
yes.
It is, right? Yeah. So it is very dynamic. You were saying like every single new proving system has a lifespan of like 6 months of being the sexy thing kind of thing.
Yeah.
But I think ZK as a technology, I think we're more and more ready for it to be adopted by Web3 first, and then later hopefully Web2.
Yeah, I would agree with that. If there's one, people harp on Web3 use cases all the time, and honestly, if there's one thing I'm really proud of about Web3, it's that we've been able to, it's incentivized the innovation, development, and research of programmable cryptography, which it sounds so like abstract and far removed, but I really do feel like programmable cryptography will build the next set of traditional products and use cases that humans will absolutely need in this era that we're moving into. So,
are we just, drinking our own Kool-Aid, Chris?
very well could be.
I wonder if there are any detractors right here, who could talk about.
Yeah, I'm curious from the audience. Do you guys have any, I guess, criticisms? Yeah, please. Any thoughts, really, but if you have...
Ooh. Jason? Oh, I do know you.
Here I go, just injecting myself into other people's panels. I apologize, guys.
You're welcome.
One of my big problems with a lot of the ZK infra is that it depends very much on extremely centralized solutions. Because it is computationally very heavy, oftentimes that means that you end up with, you know, a small number of very powerful machines that handle the computation for this, and then the storage for it. I mean, I'm aware of one particular solution that has a big-ass Google Big Table that everything lives in, which is not ideal. And so what I'd like to hear more about in the long term is what the deeper decentralization of this looks like and how this can be achieved in a way that makes it a little bit more trustless and a little bit less, we built a really cool big thing that processes lots of transactions, but you know, it's all kind of in-house. Sorry.
Can I respond quickly and then maybe the tech people can dive into that? So, thank you, Jason. And we did not set this up. I did not ask Jason to ask a question.
No planted questions.
No planted questions. So for ZK Verify, we're going to be decentralized for sure. So we are kind of like an L1, L0, a bit debatable. But the whole idea is that once we launch proper mainnet, we will be decentralized. So to us, that's very, very important in verification in general. So I know that's super high level, but I'll leave it to Chris and Sinka.
Sinka, would you like to respond?
So yeah, at the moment, the trend will be proof is made in a centralized cluster, but the verification can be decentralized. And at the beginning, the whole point of the ZK is that you can hide in the witness, right? So that means it has to be calculated centralized way, but everyone can believe that so that the verification is decentralized. But nowadays, there's a trend. There's something called memory-friendly provers that probably can do decentralized MPC CK proof. But I personally did not find any use case on decentralized proof. But I do believe that decentralized verification is a good consensus way. Thanks.
Nice, yeah, and my response would be, I mean, there are decentralized proving schemes such as risk zeros, risk zero proofs. Essentially, what they do is they split up a proof into different segments. They send those segments out to different provers, and those provers individually prove their segments, and they get aggregated back into a larger proof. So that's also called a recursive proving scheme. Now, that doesn't solve the whole private witness issue that Sinka is talking about, for which, there are MPC schemes available. I think those are still more cutting edge. I think TACEO is a really good company who's innovating here. They're doing co-snarks, which is essentially to say that you can collectively generate a proof without knowing what the private input is using MPC. Could go down that hole, but probably for another time. But yeah, thank you for the question. Any other questions here before?
Post-quantum.
Boom. Absolutely.
Nice.
Absolutely.
Nice.
Yeah, so just for context, most of the cryptography that underpins our validity, and we really should have clarified between validity proofs and ZK proofs. But really, all of the cryptography underpinning both of those proofs massively rely on elliptic curve cryptography, both of which elliptic crypto is quickly being is quickly at risk of being broken. We have U.S. government standards for post-quantum cryptography being already standardized. The NIST, National Institute of Standards and Technology, is deprecating elliptic curve crypto by 2030, disallowing it by 2035. So yeah, post-quantum proofs definitely need to come. They need to come fast. Awesome. Well, I think that's all the time we have for one more question. Yeah, go ahead.
So my question is, you were talking about adaptation of ZK. So my biggest thing about ZK is that I find it's kind of difficult to understand. So because blockchain is already complicated as is, but ZK kind of adds another layer of complication to the whole blockchain space. So, so my question is there a way to simplify ZK for a new user?
ZK Verify. Hello. Yeah, I mean, so the whole idea for developers is that it's supposed to be much easier. You come to us, and we work with all the different partners, and you can just verify. So I would say for that part of the stack.
And my TLDR would be ZK allows you to bring the world's data centers on-chain, where we've been so far restricted to computations that can be done on a blockchain, very expensive, very slow. ZK allows you to bring off-chain computation on-chain. That's how I think about it.
Sinka?
That's too hard. This question is too hard. Okay, it's too hard for me.
No problem.
But I think to respond to you, I think you're right? Everything is very dynamic and is extremely complicated. I can tell you firsthand, like I just joined 1 month ago, and I told them like I can't dive into the technicals, right? It's very, very technical, obviously for me as a non-technical person. But when I talk to internally our product team, like 1 or 2 people on a product team who are not the engineers, and it's like, yeah, no, they're still learning every day. So I think that's testament to how technical this field is.
It is indeed. But yeah, thank you so much for the question, and thank you all, the audience, for your time and consideration, and we appreciate it so much. Thank you to our panelists.
Thank
Cheers
you.
all.
Thank you.
Thank you. Have a good day.